Welcome, everyone. I'm excited to kick off today's presentation on damp proofing. This is the first slide, and it sets the stage for what's to come. We'll be exploring key concepts, techniques, and best practices for effective damp proofing. So, let's get started and see how we can protect buildings from moisture issues. Let's take a closer look at what damp proofing actually is. According to the American Society for Testing and Materials, or ASTM, damp proofing is a material designed to resist the passage of water when there's no hydrostatic pressure involved. In simpler terms, it's meant to keep moisture out of buildings in situations where water isn't pushing hard against the surfaces. On the other hand, waterproofing refers to treatments that can withstand water pressure, effectively blocking water from penetrating even under pressure. Now, it's important to understand that damp proofing generally focuses on preventing moisture from entering the building, especially from the ground or external sources. Meanwhile, vapor barriers are a bit different. They're used inside walls to stop interior moisture, like humidity or condensation, from seeping into the wall cavities. Connecting this to our overall theme, effective damp proofing and vapor barriers are essential components in maintaining the durability and integrity of a building. They work together to control moisture, which is key to preventing issues like mold, decay, or structural damage down the line. Let's start by talking about treatments to basements in damp soils. When dealing with dampness in basements, the key is to prevent moisture from entering the space in the first place. This often involves waterproofing the exterior walls, such as applying sealants or membranes, to create a barrier against groundwater. Additionally, improving drainage around the property is crucial. Making sure gutters and downspouts direct water away from the foundation can significantly reduce moisture buildup. Sometimes, internal drainage systems or sump pumps are installed to manage any water that does get in. The goal here is to keep the basement dry and prevent the issues that damp soils can cause, like mold or structural damage. Now, moving on to treatments for floors. This is equally important because floors can be a major pathway for moisture ingress. Treatments often include applying damp-proof membranes or coatings directly onto the floor surface. Ventilation is also critical. Ensuring proper air circulation can reduce humidity levels inside. In some cases, installing vapor barriers or insulation can help prevent rising damp from the ground. The overall aim is to create a dry, healthy environment inside, which not only protects the structure, but also improves comfort and safety. Remember, both these treatment strategies, whether for basements or floors, are essential parts of a comprehensive approach to managing dampness. They work together to safeguard the building's integrity and enhance the living or working conditions inside. Let's take a closer look at the methods of damp proofing, starting with membrane damp proofing. This approach involves placing a layer or membrane of a waterproof or repellent material between the source of the dampness and the structure itself. Essentially, this layer acts as a barrier to prevent moisture from penetrating the building. The materials used for this purpose are quite diverse. Common ones include bituminous felts, which are bitumen-coated felts that are flexible and durable. Mastic asphalt is another option, known for its waterproofing properties. Silicone and epoxy coatings are also popular because of their excellent resistance to water and chemicals. Polymers, plastics, or polythene sheets are lightweight and easy to install, providing effective waterproof barriers. Cement concrete can also be used in some cases, especially for more robust, structural damp proofing. Now, a very important concept to understand is the damp proof course, or DPC. This is a barrier embedded within the masonry wall designed specifically to resist moisture rising through the structure by capillary action, what we call rising damp. The DPC can be installed either horizontally or vertically, depending on the construction requirements. Typically, you'll find the DPC laid below all masonry walls, whether they are load-bearing or partition walls. This layer is crucial because it helps prevent moisture from wicking up from the ground into the walls, which can cause serious problems like mold, decay, and structural damage. So, in the overall picture of damp proofing, the membrane and DPC work together as essential protective measures to keep our buildings dry and durable. Let's talk about DPC, or damp-proof course. It can be installed either horizontally or vertically, depending on where the dampness is coming from, whether it's on floors, walls, or other surfaces. The main goal is to prevent moisture from rising through these structures. Now, a damp-proof membrane, or DPM, is a special membrane material that we apply specifically to block moisture transmission. Think of it as a barrier that keeps water from seeping through the building elements. Moving on to integral damp proofing, this is a slightly different approach. Instead of adding a barrier afterward, we incorporate waterproofing directly into the concrete itself. This involves adding certain materials to the concrete mix to make the concrete inherently impermeable. These waterproofing compounds can be introduced in either liquid or powdered form. When mixed with the concrete, they react chemically to enhance its waterproof properties. Some common chemicals used are alkaline silicates, aluminium sulfates, and calcium chlorides. These compounds react with the concrete to produce a waterproofed structure, effectively sealing it from moisture ingress. Commercially, there are pre-prepared waterproofing products like Pudlo, Permo, and Impermo, which are added directly to cement to achieve this effect. So, in essence, integral damp proofing makes the concrete itself resistant to water, providing a permanent solution within the structure. This method is especially useful where traditional damp-proof courses might be less effective or practical. Integral damp proofing is a key method we use to protect structures from moisture ingress. It involves incorporating waterproofing materials directly into the building's construction, often during the foundation or wall build. This approach creates a seamless barrier, making it highly effective at preventing rising or lateral dampness from affecting the interior spaces. One of the main advantages is that it becomes an integral part of the structure, so there's less risk of damage or failure over time. When we talk about overall damp-proofing strategies, integral damp-proofing plays a crucial role because it offers long-term durability and peace of mind. It's particularly useful in areas prone to high moisture levels or where traditional surface treatments might not be sufficient. So, by embedding waterproofing into the very fabric of the building, we ensure better protection and extend the lifespan of the structure. Let's now look at surface treatment, which plays a crucial role in protecting buildings from moisture. Essentially, this involves filling the pores on the surface where water can seep in. By doing so, we create a barrier that reduces the chances of moisture penetration. One effective method is using water-repellent metallic soaps, like calcium and aluminium oleates. These substances are quite powerful in safeguarding the building, especially during heavy rains, by making the surface water-resistant. In addition to these chemical treatments, applying a cement-lime plaster in a 1:6 ratio is also beneficial. This plaster helps prevent dampness in the walls caused by rain, acting as an extra layer of defense. Now, moving on to cavity wall construction, this is another smart approach for damp prevention. The main idea here is to have an outer wall or an outer skin that shields the interior structure. Between the two walls, there's a cavity left intentionally. This design, often called rain screen construction, separates the interior from the exterior walls by this gap. The cavity allows any water that gets past the outer layer to drain or dry out, preventing it from reaching the inner walls. So, in the overall context of building durability and moisture control, both surface treatments and cavity wall construction are vital strategies. They work together to keep buildings dry and structurally sound, especially in heavy rain conditions. Let's talk about gunniting, which is a key waterproofing technique. Essentially, it involves depositing a dense, impervious layer of cement mortar over the surface we want to waterproof. This mortar is typically mixed in ratios like 1:3 or 1:4, and it's shot onto the prepared surface under a pressure of about 2 to 3 kilograms per square centimeter. When doing this, it's important to keep the nozzle of the cement gun at a distance of roughly 75 to 90 centimeters from the surface to ensure even application. After applying the gunniting, the surface must be cured for at least 10 days to achieve the desired strength and waterproofing effectiveness. Now, moving on to pressure grouting, which complements gunnaiding quite well. This method involves forcing cement grout under pressure into cracks, voids, or fissures within the structural components, or even in the ground itself. It's particularly effective in preventing seepage of groundwater through foundations or substructures, which is often a major concern in waterproofing. Both these methods, gunnaiding and pressure grouting, are crucial for ensuring the durability and watertight integrity of structures, especially in challenging soil or water conditions. They help in protecting the building's foundation and overall stability, aligning perfectly with our goal of creating resilient infrastructure. Let's take a closer look at the materials commonly used for damp proofing. First, we have flexible materials, which are quite popular because of their ability to adapt to movement and cracks. These include butyl rubber, hot bitumen, plastic sheets, bituminous felts, and even sheets of lead or copper. Their flexibility makes them effective in creating a continuous barrier against moisture. Next, there are semi-rigid materials like mastic asphalt. These are somewhat less flexible, but still provide a good seal, especially in areas where some movement might occur. They strike a balance between flexibility and rigidity. Moving on to rigid materials, these are often used for more permanent solutions. Impervious bricks, stones, slates, and cement mortar or concrete coated with bitumen are common examples. These materials are highly resistant to water penetration and are suitable for structures that require a sturdy, long-lasting barrier. We also see natural stones being used, which can be effective in certain applications due to their durability. Additionally, mortar mixed with waterproofing compounds enhances the water resistance of masonry. For floors, especially, layers of coarse sand are spread underneath to facilitate drainage and prevent moisture from rising. Continuous plastic sheets are another excellent option under floors. They act as a robust barrier to moisture ingress. Overall, the choice of material depends on the specific requirements of the building and the level of damp proofing needed. Selecting the right materials ensures durability and helps keep moisture out, protecting the structure over time. Let's explore the various damp proofing treatments used in buildings. First, we have treatment to foundations, which is crucial because foundations are the base that supports the entire structure. These treatments vary depending on the type of soil. For foundations on ordinary soil, we apply standard damp proofing methods to prevent moisture ingress. When dealing with damp soil, more specialized treatments are necessary to ensure moisture doesn't seep into the foundation, which could lead to structural issues. Moving on to basements, the treatment differs based on whether the soil is ordinary or damp. Basements in ordinary soil require a different approach compared to those in damp soil, where waterproof membranes or coatings are often necessary to keep moisture out and protect the interior. Next, we look at treatments to floors, which are essential because floors are often exposed to moisture coming from below or from the atmosphere. Proper damp proofing here ensures the comfort and durability of the building. Similarly, treatments to walls are vital in preventing rising damp or lateral moisture penetration. Effective wall damp proofing maintains the building's integrity and prevents mold growth. When it comes to flat roofs, the focus is on waterproofing to prevent leaks and water damage. Pitched roofs also require specific damp proofing measures, especially around joints and edges where water might penetrate. Lastly, treatments to parapet walls are important because these are exposed to weather elements and can be vulnerable points for moisture ingress. Overall, these various damp proofing treatments form an essential part of maintaining building durability, comfort, and safety by effectively managing moisture ingress at different points of the structure. Today, I will discuss the treatment methods for foundations based on the type of soil they are built on. First, let's look at foundations on ordinary soil. When the soil is ordinary and the water table isn't high, brick masonry below ground level can absorb moisture from the surrounding ground. This capillary action causes the walls to become damp, which can lead to structural issues over time. To prevent this, we typically provide a damp proof course, or DPC, positioned at least 150 millimeters above ground level or the plinth level. This acts as a barrier to moisture rising through capillary action. Now, let's consider foundations built on damp soil, especially in wet areas. In such cases, both the walls and the ground floor are at risk of becoming damp because moisture rises from the ground through capillarity. To address this, we lay a DPC over the entire ground floor area, including the thickness of the walls. This ensures that moisture cannot penetrate into the structure, protecting it from dampness and potential damage. Understanding these treatments is crucial because they form the foundation of durable and moisture-resistant buildings. Proper moisture control not only enhances the longevity of the structure, but also ensures a healthier indoor environment. Today, I'll be discussing treatment methods for foundations, focusing on two common scenarios we encounter in the field. First, we have treatment to foundations built on ordinary soil. In these cases, the soil properties are generally stable, but we still need to ensure proper support to prevent settlement or shifting over time. This often involves techniques like soil stabilization, compaction, or using deeper foundations to reach more stable strata. Next, we look at treatment for foundations on damp soil. Damp soil presents a different challenge because excess moisture can weaken the soil structure and lead to uneven settlement or even failure of the foundation. Here, strategies include moisture control through drainage, waterproofing, or soil drainage systems to keep the soil dry and stable. Understanding these two scenarios helps us choose the right treatment approach, ensuring the longevity and safety of the structure. It's all about adapting our methods to the specific soil conditions, which ties back to the core goal of effective foundation engineering. Now, let's look at the treatment methods for basements built on ordinary soil. When the subsoil water table is low and there's no water pressure, we typically use a combination of horizontal and vertical damp-proof courses, or DPCs. The horizontal DPC is installed over the entire floor area, creating a barrier to prevent moisture from rising through the ground. On top of that, vertical DPCs are applied on the external faces of the basement walls to stop moisture from seeping in from outside. To start, we apply a primer coat of hot bitumen, about 1.5 kilograms per square meter, over the prepared surface. This primer helps the subsequent layers adhere better and provides an initial moisture barrier. Once the primer is set, we lay a single layer of bitumen felt over it, which acts as a waterproof membrane. This combination of primer and felt forms an effective moisture barrier, protecting the basement structure from dampness. These methods are essential in ensuring the durability of the basement, especially in areas where groundwater conditions are favorable for such treatments. Overall, this approach aligns with our goal of providing reliable waterproofing solutions for basements on ordinary soil. When it comes to treating basements built on ordinary soil, there are several important considerations to keep in mind. First, the primary concern is ensuring proper drainage around the basement to prevent water accumulation, which can lead to dampness or even structural issues over time. Next, it's crucial to evaluate the soil's bearing capacity. Ordinary soil can vary quite a bit, so understanding its properties helps us determine the appropriate foundation design and any necessary ground improvement techniques. One common approach is to use a waterproofing system, such as membrane barriers or coatings, to prevent moisture from seeping through the walls. Ventilation also plays a key role in controlling humidity levels inside the basement, reducing the risk of mold and other moisture-related problems. Additionally, foundation design might include the use of proper drainage layers, gravel backfill, or even soil stabilization methods if the soil has poor load-bearing capacity. All these measures are connected to our overall goal of creating safe, durable, and comfortable basement spaces, especially when working with typical, everyday soil conditions. By addressing these factors thoroughly, we can ensure a long-lasting and maintenance-friendly basement. When dealing with basements in damp soil, especially where the groundwater table is high, we need to take specific measures to ensure durability and prevent water ingress. One common approach is to provide a comprehensive foundation system that includes proper drains and a DPC, or damp-proof course, to block moisture from rising through the walls. Another effective method is constructing an RCC raft along with wall slabs, which gives additional strength and helps in water resistance, coupled with a DPC to further prevent moisture penetration. Additionally, waterproofing treatment plays a crucial role. This involves using grout made of mortar mixed with acrylic-based chemicals, which significantly enhances water resistance. Sometimes, stone slabs are used in conjunction with this treatment to form a protective barrier. Moving on to floors, the key is ensuring a solid, well-laid stone soling, which is properly rammed to prevent any shifting or settlement. For the top layer, we usually use tiles, stones, or cement concrete, depending on the specific use and aesthetic requirements. All these steps are vital in creating a basement that remains dry and durable, aligning with our overall goal of building resilient, long-lasting structures. When we talk about treatment to walls, it's important to understand how moisture can actually enter the structure. Often, moisture seeps in from the external face to the internal face of the wall, primarily due to the porosity of bricks and mortar joints. This porosity allows water to penetrate, leading to dampness inside. To combat this, there are several treatments we can apply to the exposed surface of the wall. These include plastering, pointing, and painting, which act as barriers to moisture ingress. One particularly effective method is applying a plaster made of cement, lime, and sand. The recommended proportion is 1:6, and this mixture can be very effective in protecting walls against dampness, especially in normal weather conditions. The key takeaway here is that proper surface treatment is crucial in preventing dampness, which not only preserves the structural integrity of the wall, but also maintains the overall health of the building. By understanding these treatments, we can better ensure the longevity and durability of our walls. Now, let's discuss treatment to walls. When it comes to walls, applying the right treatment is essential for both protection and aesthetics. This involves selecting appropriate wall finishes, such as paints, coatings, or specialized treatments, depending on the environment and the type of wall. For example, in areas prone to moisture, waterproofing or mold-resistant paints are key. Proper surface preparation is also crucial to ensure these treatments adhere well and last longer. Additionally, treatments can serve functional purposes, like fire-resistant coatings, or decorative ones, such as textured finishes or murals. Connecting this to our overall theme, effective wall treatment not only enhances the durability of the structure, but also contributes to the safety and visual appeal of the space. So, always consider the specific needs of the environment and the purpose of the space when selecting wall treatments.